When we're asked to solve a trig equation, we're trying to find an angle that gives us a sine, cos, or tan of a particular ratio. So what's important is to look at what the target is. Are we trying to get a ratio that is 0 or 1, in which case we're just using the unit circle, or are we trying to get something that's not 0 or 1, in which case we have to do something different? Okay, so let's start with the easy case first. So looking for cosine of an angle that is 0. I know that cosine is the x-coordinate on the unit circle. So from my unit circle, I'm just going to put these angles on before I get too confused. Okay, so I'm just hunting around looking for x-coordinates that are 0. So there is one, and there's another one. So my solutions are pi on 2 and 3 pi on 2. Okay, those two angles have a cosine of 0. Notice that it's just between 0 and 2 pi, so these are my only two solutions. If instead it was between 0 and 4 pi, so pi on 2 is a solution, I could go around the circle again and get to that same angle. Effectively, I can add 2 pi to both of those solutions to generate more solutions. In a similar way, I could also subtract 2 pi if I needed to generate more solutions. Perhaps instead of being less than 0 is maybe from negative 2 pi to 4 pi, generate a whole bunch more solutions. So when the target isn't 0 or 1, I can still use the same sorts of ideas. So again, I know that cosine is the x-coordinate. I could look at this massive unit circle and just look for where cosine is a half or negative half. So looking for x-coordinates where it's negative a half. So here is 1, here is 1, and there's some over here where it's positive. Okay, so they'll all give me some clues about how to figure this out. What I know about these 4 angles that I've circled is that this angle on here is pi on 3. Okay, the angle of the x-axis is pi on 3 in all those cases. Okay, so if I had this diagram in my exam, I could just simply say, hey, cosine x is negative a half. That gives me these two values, 2 pi on 3 and 4 pi on 3, the ones where it's negative. Unfortunately, I don't have this in the exam, but I can sort of use that principle to try and solve this trig equation. So my first job is to find what this small angle is. So this pi on 3 that is common to all these angles, I'm going to call the acute angle. And the way I'm going to find it is just by doing cosine inverse of a half. So I know there's a negative there. I'm just going to ignore it for the purposes of finding that small angle. Looking at my exact value triangles, looking for an angle that has adjacent over hypotenuse of a half. So here, 1 over hypotenuse, no good. Adjacent over hypotenuse, that looks good. Okay, so my acute angle is pi on 3. So this tells me that if I want a cosine value of a half, I need an angle of pi on 3 off the x-axis. I'm after cosine being negative, and I know that cosine is negative in 2 quadrants. Okay, it's negative in quadrants 2 and 3, okay, where the x-coordinates are negative. So I can draw up my sort of unit circle. Here's 0, here's pi. In quadrants 2 and 3, I'm going to just put pi on 3 off the x-axis, and I can find my two solutions. So this is pi minus pi on 3, and this one will be pi plus pi on 3. So my solutions will be pi minus pi on 3, which is 2 pi on 3, and pi plus pi on 3, which is 4 pi on 3. Okay, again, it's just for 0 to 2 pi. If I wanted more solutions, I could add 2 pi or subtract 2 pi, either way. And check it out, there's the two solutions that we found from that mess of the unit circle. Okay, so this unit circle doesn't exist when we're doing our solution. We can do the whole thing by ourselves.